Good morning, everybody. Welcome to the biweekly Subspace Integrations Sync. This is the first of a new type of call we're going to have, where we're going to discuss integrations with other ecosystems, like layer one ecosystems like Sama or Ethereum, specifically around the relayer or the archiving of other chains into the subspace history, and also specifically what we're doing with NFTs right now. So Leo, if you would like to start off, and we can cover what you guys did at the last hackathon with Metavault.
Sure, I'm going to share my window. Screen one, screen two. Well, I think that Justin made this diagram, and he expressed it really well. What we in a high level we made for this hackathon. We basically created the app that connects to Ethereum and also Polkadot, actually our network, Subspace. And it's able to create NFTs and attach metadata, upload this metadata to Subspace and also Ipfs. And the concept in here is that we are just creating a Metavault. What is this? This is some kind of container that is able to contain different NFTs. And also those NFTs are linked to a metadata that is stored somewhere else. In this case, the Subspace network and the Ipfs. And Ipfs. And finally, after creating all these collections of NFTs and the NFTs itself, the app is able to publish this NFT in OpenSea so people can view this listed in OpenSea and actually buy this NFT or sell this NFT. So I am going to do a fast walk through to the code, and let me know if I am going too fast or if you got some questions in there.
Before we go through the code, Leo, could we just do a demo just to see how it works?
Sure. Can you see Firefox in here, right?
Yeah.
So this is the landing of the app, and as you can see, you are forced to connect to Ethereum with MetaMask and to Subspace network with Polkadot extension. So I already have this the app connected and with the permissions granted, and already have a Subspace network running. And the first step, as you can see, guys, is to create an NFT collection. I'm going to create just a test collection. And this is basically the vault that will contain all the NFTs that I am creating. I am basically creating a marketplace, my own marketplace. I am creating the collection itself, the contract, deploying the contract, and the same with the NFTs. I am creating the NFTs, minting the NFTs, and link it to this collection.
I have a question. The collection is a concept at OpenSea, or what is it?
It's a concept of it's an standard, an NFT standard called NFT. Sorry, ERC.
ERC 71.
71, and another one actually. 1015, I think. There is another
1155.
1155. It's basically a wrapper of NFTs.
Can you create an NFT without collection?
Yeah, for sure.
No?
This is some kind of extension.
Okay.
Yeah, you can create the NFT itself, the 7021, like like any other token.
I believe you can theoretically do it, but it wouldn't fit the standard. The standard was actually designed so that you could organize NFTs better in these collections versus as individual items.
Right, it just seems like an additional step before you can actually get to like the meat of the product to like create an actual NFT.
Yeah, so I am going to create this collection. And as you can see, it's...
So is collection itself an NFT?
Yeah, it's also an NFT.
Image?
The collection is a contract. The contract has state, like a state database within it, which says what NFTs there are and who owns them.
Okay.
Yeah. So what is happening right now, as you were able to see, I got two pop-ups from Polkadot. One is for the metadata of the collection, and the other one is the logo of the collection that I was already uploading. So these two fields basically are bytes data that I am storing in Ipfs and also backing up in Subspace. So it asked me to send these two files in two separate transactions. So the first step is that we upload the files, the metadata generated, and after that, we deploy the contract with all these Ipfs IDs and these objects IDs from Subspace. So as you can see,
Leo, sorry.
Yeah.
So the first step is deploying the contract to Ethereum.
Yeah.
Okay, so you have an ERC 721 contract on Ethereum, and then there's what's actually being written to Subspace in that transaction?
In this transaction, we are generating the files and storing these files in Subspace. After that, we get these objects IDs from our Subspace feature, from our Subspace store.
And what are the files? Like, what's the content of the file?
In this case, the logo for this collection.
Oh, so that's like the art, the image.
Yeah, this is the
okay.
Image
So
that
the NFT
uploading.
is just a Subspace logo in this case.
Exactly. It's a collection.
Okay, but you said there was two transactions into Subspace.
Yeah, that's confusing.
One is logo and the other one is what?
It's the metadata. In the metadata is just a JSON of all this data, the symbol, the test collection, and everything.
Isn't it supposed to be on Ethereum?
It is also in Ipfs, actually. Yeah.
Okay.
So
and in the contract itself. It's like a copy of the contract data itself, actually.
So you're just making a copy of the data that's already being written to Ethereum and storing it on Subspace, the metadata?
Yeah. So there are those are these two files: a JSON with the NFT data and the logo also. And in Ethereum, we have the contract with these two IDs.
Shouldn't you upload an image first and then get like an ID or a hash of it, and then create a contract?
Yeah, that's exactly what happened. Maybe I can repeat the process. Maybe I can repeat the process.
Okay, so
yeah, let's create another collection, and you will see that. But the first thing that it does, if right now we are not doing anything, and I just make this input of data and create this. I will create this.
Okay, so we've briefly uploaded to Ipfs. Now we are uploading to Subspace.
Yeah.
What is this?
So this is the first file that I am uploading to Subspace. That is the logo itself of the that I just selected in this input file, right?
Okay.
So I send this transaction, and now that I have this logo object ID, I have all my data of the collection itself, and also this ID for this logo in Subspace. So I generate a JSON and a JSON file with all this data, and also send this JSON data to the Subspace network as a file. So we have 2 files on each collection.
So that's
and now
where
that I
I'm
have
confused.
all this information,
sorry, I got a question. So that's where I'm confused. Why do we have to upload the JSON to Subspace? Isn't that JSON already stored in the ERC 721 contract?
When I was developing this, I realized that is like the standard, like all the NFT contracts like have this link to this JSON file that contains like a set of data of the contract, like a copy of it.
It is strange though, because it can be different from what's actually on the chain. Potentially.
Yeah, potentially.
So what is stored on Ethereum smart contract is only a reference to this JSON, right?
Exactly. Yeah. I made it this way because we don't have a like smart contract in our chain. Maybe having a smart contract in our chain, we can do something more more complicated, more advanced.
Okay, so JSON is not stored on Ethereum, just a link to that JSON.
Yeah. In Ethereum, it's just the contract with all this data, the name, the symbol, and all these fields are actually default fields on any NFT, the name or on any token actually.
So I guess this is because it's expensive to store data on Ethereum and expensive to modify. That's why they just have a link.
Exactly. Yeah.
But what is actually stored on Ethereum then for this particular collection or NFT?
The tokens and the object IDs as a reference.
So it's basically just like an index of the NFT in the collection and then some pointer to some off-chain metadata JSON file.
And it's actually the same way that people does today with IPFS. We are just adding in this tab, we are just adding an extra layer of storage, like as a backup for savings in some way.
Okay, and what is the pointer on Ethereum? What is that like address format?
Oh yeah, it's just a hash, a string in the contract that points to an IPFS address or our Subspace JS object ID.
What you said, or which one does it actually do?
Both. I have both stored in the contract.
Okay, so it's basically a tuple of IPFS content ID and a Subspace object ID.
It's a map actually. Yeah.
Okay, and then that IPFS ID, how is that pinned into IPFS, or is it just announced?
No, it's a hash actually. We upload this to IPFS, and IPFS send us the hash of the file.
Right, but someone needs to store that file. Like, where is it stored?
No, I am using a free for this demo, just a free service.
Okay.
Yeah.
Okay. And the IPFS.
You can use Pinata or any other like layer, but it's optional.
Yeah. Also.
Right, and it's centralized too. Okay, so there's 2 independent IDs. There's not a dependency between them. It's not like you have to like look up like Subspace to get the IPFS hash or look up IPFS to get the Subspace ID. There's just 2 different pointers that point to 2 completely independent networks.
Exactly.
Okay.
It can be confusing, but it's the way that I was able to do it at that moment. So now that we have all this collection data, the files and the token information, I am deploying the contract with all this information. And it's deploying.
It should really block the create button. Otherwise, you would think nothing happens. Like it's not Clear.
And there is completed. So as you can see now, we have these two collections in here. And now I can create an item, an NFT itself. And actually with the NFT 721 standard also. That is just a token standard with the name, the description, also a file, maybe an external link if you want to add a third backup in a centralized, I don't know, S3 or something, Google Drive, anything. And you can also add attributes to this NFT and also set a price to sell the NFT. So I'm going to select this collection, that is the test collection 2. NFT test 1. So description and a logo.
So all of the fields, including attributes, are part of the NFT and prices for OpenSea, I guess?
Yep. Price is actually for OpenSea, exactly. So I'm going to do this create, and it does the same flow that before, actually. It's upload the file to Ipfs and Subspace, backup the file to Subspace. Pop-ups in another window. And now store the NFT metadata. And now what it does is the same as before, but in this case, I'm going to just mint before we have already deployed the contract. So I'm going to mint a new NFT, and it will be linked to this collection with all the metadata and the Subspace logo, in this case, attached to this NFT data.
So the first thing you did was create a collection, not actually an NFT, but there was an image and some metadata associated with that collection. Now you're creating an NFT in the collection that is the actual logo.
Exactly.
Okay.
So the collection is some kind of vault. It's the vault itself. And in here, we are waiting just 13 seconds to wait if there is some delay between OpenSea and Ethereum. And after that, we automatically list this NFT, the result NFT, or on OpenSea with this price set it in here. So let's wait.
So there is no moderation on the OpenSea?
No, you just have to. Oh, I have to register the proxy.
It's just like it's just a HTTP API, right? You just do a put.
Yeah, and you send the query, and OpenSea lists it like instantly. I think that for Rinkeby there is no limits, but I think that you're right. In production, you have to get an API key, I think, to be able to list or use the API itself actually on OpenSea. Pretty much. There is. Oh, and now I have to create a signature that is attached to the OpenSea request, actually, to grant permissions, just to send the message. And now the NFT itself, it's listed in OpenSea, as you can see here. And here we have the test collection that has this Subspace logo, and also the price we set it, and some information about it. Yeah, and that's it, I think.
That's a lot of steps and pop-ups and confirmations.
Yeah,
and a lot of wallets.
Yeah.
Yeah.
To do this two-side integration, it was the only way. Maybe like Serge mentioned, we can create a service that make this easier with a backend. I don't know, but at that moment, I have to connect with these two networks in the app, and the fastest way was with these extensions.
So on the upload side, we can potentially determine on the front end what the hash of the object will be. And we can send a batch transaction which uploads the file and metadata like in one step. And if you were to like create a collection, we can add another transaction in there and like upload everything as one step.
Yeah.
So we'll like reduce the number of pop-ups at least.
Yeah. We can probably, and create the transaction and just send it in just one step.
I think it won't help for most users, like because people are not comfortable using two wallets on the same application. I mean, MetaMask is the standard, so
it's already
everyone,
too much actually.
Yeah, but using MetaMask and Polkadot, even if you need just one transaction, people will hate it. So I think it would be nice to have some kind of like smart contract on EVM or price oracle that will calculate the price of the storage for a particular asset, and people can use only MetaMask for that. Like the integration should be on the platform side, not on the user interface.
Right, but we are talking about decentralized implementation ideally.
Yeah, I'm talking about smart contract and price oracles.
So how would you upload something to Subspace without connecting to Subspace? You cannot proxy through Ethereum because that will be expensive. You cannot like upload data to Ethereum for that to be read later by Subspace. Like,
well, at this stage, I don't know because I didn't really had a chance to think about this, but I think we should target experience where people don't have to use Polkadot.js. Because I don't think anybody will use it.
Well, I had an idea of this situation where you can potentially pre-purchase some number of bytes on the network and use it like later. Then like the application developer can like give you some of those bytes to upload your file without you necessarily paying for it.
Yeah, it's actually called fuel tank. Like Affinity uses this concept, and it's possible on Near. Like you can prepay gas for your users.
Which chain uses that? Sorry, Serge?
Near.
Near.
Yes, they have option to prepay gas.
So you have some kind of contract with all the prepaid accounts, and
like
you
basically
offer this like a service.
You can subsidize your users, like a freemium, you know.
Isn't that like ETH gas station as well? Or not ETH gas station? What's it called? The gas network, something like that on Ethereum. That does something similar.
I heard something, but I don't know. I'm not aware. And if Affinity, which is a parachain on Polkadot, I read their white paper. They have also this concept of fuel tank, because for NFTs it's even more critical because gamers don't want to pay before they try, right? They don't really care about NFT and stuff until they really have understanding. So what they offer is this concept of fuel tank that platforms can subsidize their users, and users can use assets from this fuel tank to mint, or we can use it for storage, or yeah.
Well, you can with the same luck just send a request to some server, and they might like sign your transaction to pay for the gas fee.
But that would be centralized, right? We don't
Yeah,
want
that will
Um,
put us like in the same
Well,
level.
if it's completely
see.
decentralized, then like anyone can basically drain your tank, like mint as many NFTs as they want for free. So
or
like,
maybe you can design it so one user can only have limited amount.
okay, that's interesting.
I think that for the beginning, like users just want to do this fast, and if we have to maybe create some intermediary service, I think that people will more appreciate that hate a centralized service or something like that. Maybe just for the beginning to do this easier.
Yeah, and it's worth pointing out that this is a very first initial raw rough step of just trying to map out what we actually have to do to get this to work versus trying to have like a perfect or great user experience. So this is just like a learning process for all of us, and we'll continue to iterate on this and get it better and better. But the first question is just like, how does it actually work? Like, what are the minimum necessary steps or the critical path to do this, which is kind of what Leo has identified. I think we can pare it down. We can work on the user experience for sure.
I also tried to in the hackathon. I tried to use Polygon because it has all this kind of concept of gasless transactions and everything. Maybe we can stop thinking so much in Ethereum and thinking Polygon also. Actually, checking the central land and everything, I realized that when they migrated all their contracts to and their live payments proxies and everything to Polygon, the central lands are actually became like useful. Before it was like a pain to spend money like in the game itself, in the world itself. And after this integration, all became like really more like, how can I say it, a better experience. People actually can now use their mana in the platform. Before it was impossible to buy, for example, a $1 t-shirt. People can do that before, and now they can do it with Polygon. It's really fast and cheap.
I'm wondering if there's something we can leverage with what Moonbeam is doing, how they're using MetaMask. If there's, I don't know exactly how that works under the hood, if that would have to be two separate accounts, or if you could use the same account and have like two tokens associated with it. There's a way that we could sort of expose Subspace through MetaMask the same way that Moonbeam does, so that you could just use the same address to somehow, not have to use two wallets, maybe two accounts. I don't know if, or maybe they could even be one account, but somehow just to make it simpler.
So the way it works, they basically have additional RPC like methods that are the same methods as in Ethereum node implementation. So if MetaMask, if you like add an RPC endpoint or select Moonbeam RPC endpoint, it sends regular requests as it would to the Ethereum node and gets reasonable replies. So it doesn't even know that it's not Ethereum. Like from the point of view of MetaMask, it's regular Ethereum. But the addresses in Ethereum are obviously different than SR25519 and like SS58 standard that Substrate uses. So I don't think it's like fully the same, unless we like have complete EVM and limit to EVM use cases.
I think I saw on Astar, which is another parachain, so they have both. It's one account, but you have two addresses. One is like EVM address, and another is standard Polkadot style. So maybe we can check how they do it.
And what do they use as their wallet interface?
No, just go to the their dashboard. Let me share the link.
Was that? I mean, is it like Polkadot JS extension, or they're using their own?
You can use multiple. You can use Polkadot.js. You can use MetaMask, I think. Yeah.
That
But
would
can
be
you
ideal.
use both for the same stuff, or you can use them for different purposes? I mean, whether you can send balance in both cases, whether you can mint an NFT in both cases, same way, and stuff like that, like whether they're equivalent.
I haven't tried balance yet, so I cannot say, but it shows like one by one, like two wallet formats next to each other. So I guess they are linked to one account.
Oh, interesting. Yeah, I'm just trying to. I can connect my regular Ethereum wallet with my regular Ethereum address into Star, so it'll let me use that to spend funds. Not sure how it's actually working under the hood, but from user experience, it seems to work. So maybe that's an idea. Maybe instead of using Polkadot.js extension, we should figure out how other people have hacked MetaMask and use MetaMask as our default interface, so there's not two interfaces.
But you still will need to switch between networks, right? You'll have it like a trigger from your application into MetaMask to ask switch to another network. You need to confirm that. Then you will get a pop-up about transaction. You confirm, and then you switch to back to like another network. So it will not be like very seamless either way.
But
Most
most
people,
that's
most
how it works
MetaMask
as well.
users are already like got used to it.
It's like switching on L2.
Yeah, if you use some DeFi protocols and you switch between like layer 1, layer 2, you still need to do that. It's super annoying, but at least you have only MetaMask.
Yeah, it feels like that's almost just more of a user experience problem that maybe the MetaMask team is already working on too, where there's like a MetaMask, where you can authorize multiple networks that are kind of behind the scenes active, and you can transact between them without having to separately switch each time.
But then we need to explain to users that yes, this is your SS58 address, but this is your also Ethereum compatible address, and which one to use and like how to send funds if you have one instead of the other. And they're not necessarily equivalent, so it's not like you can just infer what the other one will be from the first one, at least in one of the directions. So I'm just wondering if it will actually confuse users. I understand like the problem that we want to solve, but I'm not sure that is ideal solution. Ideally, it would be like a wallet which supports both Substrate-based chains and Ethereum. And you can select network on each and like use them in parallel somehow. Like a meta transaction, like multiple steps for different networks that are just happening sequentially somehow. I don't know.
Yeah, you just move complexity to the wallet.
Well,
Meta wallet sounds like a meta service.
User doesn't care like how wallet is implemented. What matters is that you have like, this is how many Subspace credits, this is how much Ethereum, confirm, done. And not like multiple pop-ups.
Okay, I think we're going on a tangent here. If we found a good problem though to think about, but let's move on.
Kind of, we have to create like our own extension. Some kind of
A separate team.
Yeah. So maybe I can just in a fast way show the code, so you can guys check the structure and have a clear view of what we made it. Here, entire screen. It's not so much. Will not take too much time, I think. Yeah, there is. Well, as you can see, the project is divided in 3 root folders. I think that
zoom in a little bit, Leo. It's a little bit
sure.
small and hard
Sorry.
to read.
maybe in there.
Yeah, it's great. Thank you.
Perfect. And as you can see in the README, in here, we have this separation of folders. The Subspace folder is just a copy of the Subspace library. In that moment, I have a release mismatch. So I just copy pasted the library in here. In the future, maybe I can remove it. And I think that the important part is this truffle project, this one that contains the contracts. It's just a truffle project that contains an NFT contract. I don't have the plugin installed, I think, the Solidity plugin. But it's just a standard ERC 7021 and the collection contract that is also an extension of this ERC 21 that is in here, and is a wrapper of the collection. And as you can see, it has some basic data, basic public data actually, that are strings. This contract URI is the Ipfs link, and in here we have the object ID for the subspace metadata and the object ID for the subspace image or the file that I sent. And it just contains a constructor that has the name, the symbol, the contract URI, and the object ID. And as you can see, these are the same fields in the form of the collection that we checked before. And it's just that it also has this mint function to mint a new NFT. And it's just that the truffle tool, for saying in some way, yeah, the truffle project has this truffle config that allows you to
Leo, we can
to
skip the part
configure.
about Ethereum development. Can you show
Okay.
us the item data structure, like the actual NFT collection item, how that looks?
The actual NFT collection.
So you showed us the collection
This
properties.
is the contract.
Where are the items?
The items are in here. Is this one? Is this contract that is let me scroll in here. Sorry, I don't know why it's not getting the Solidity plugin. It was working before. I have everything in just one file. Sorry. It's in here. This is the item itself. This is the contract that is an ERC21 that contains the token name. And in the same way that the collection are the same fields in that in the front that we check in the front end, is the name, the symbol, the description, and the object IDs and the Ipfs IDs. And it has a constructor that initializes this item, this NFT, with the same data that the form, the name, the symbol, and the object ID and the Ipfs link. I don't know if have had any question.
That makes sense to me. Any questions on the Solidity code? No? Okay.
Interesting how they have underscores on both sides.
Can you show us how you publish it to Ipfs?
Yeah, let me check in here. We have a couple of services. And in here, we need to upload to Ipfs and a provider, in this case, a free provider from Infura or Infura. And when we upload to IPFS. I think that it was in here. Here it is. This is the when we click create, the create button in the collection or in the NFT, the flow is the same. In this case, this is the item click, the item deployment, and what we are doing is just validating some field contracts. That is a number, the price, and everything. And what we are doing here is uploading to IPFS. What are we uploading to IPFS? The file that we already get from the HTML input, right? And in the same way, we are taking this file and putting in Subspace as an array buffer of actually a uint 8 array. And we in here we create the IPFS, and here we back up to Subspace, the file itself. And after that, we create this JSON of metadata that contains the metadata of the item itself. And in the same way, we transform this we send this to IPFS. And in the same way, we get this JSON and encode it as a text to send this to Subspace as a uint8 array. So we are up to here. We already uploaded the file to IPFS and back it up to Subspace, and also the metadata to IPFS and to Subspace. And after that, we mint the NFT with all the previous data that we get from IPFS and Subspace. And getting this mint receipt, we basically get this delay of 13 seconds to list on OpenSea and create this sell order based on the price we put in the form. And after that is done, is just set successfully listed, and you can go back to OpenSea and check the file. And as you can see, this is the component for the create item. And how we do this, actually, as you can see, we have this provider util that basically instance a contract for an ABI. And this ABI is what we got from the truffle deployment, from the truffle compiling process, right? Where you have this JSON that contains all the methods and it's basically the definitions of all the interfaces, a complete interface of the contract itself. So this way, Web3 has a way to map the contract with the data and everything. As you can see, is the name, the symbol, the contract UDI, the object ID is a map of variables and methods and everything. And the bytecode, actually, of the contract itself. So using this ABI, the library is able to consume and send all the methods for the ERC21 token in this case.
Okay, thanks, Leo. I think that covers most of what's interesting or unique here. Unless there's anything else you wanted to add that's specific to Subspace.
No, just note that in the collection is almost the same thing, as you can see. And
right.
Yeah, we can improve a lot this code. I basically copied this a lot from a previous project and everything, and there's a lot to do in here. Yeah.
That was a hackathon, so we won't
Yeah.
be too hard on your code quality.
Thanks.
Great. Well, that's amazing that you were able to put that together so quickly.
Yeah, it was fun. Fun weekend.
Okay. Any other thoughts or comments here?
No, I think that's everything. Yeah.
Any questions, guys?
I have a question, but it's more like from the product perspective. So here we have integration with OpenSea, right? But OpenSea only supports 3 chains, at least at the moment: Ethereum, Polygon, and Clayton. I don't know what that is, but obviously we want more chains. So how do we address it? Are we going to drop OpenSea or integrate with specific marketplaces on other chains?
Well, so first off, OpenSea was not, that was just like a,
I understand. Sponsor API.
An improvement. It's not necessarily part of MetaVault or its like roadmap or anything like that. So, and I think it was probably a little bit overkill for this as well. So I wouldn't worry too much about that. It's if anything, we probably want to integrate more with something like Zora or like a cross-chain kind of a Zora, which is like the Uniswap equivalent of OpenSea. It's like a decentralized version of OpenSea. But from my point of view, from a product perspective, like I think OpenSea is something that we need to figure out how to integrate with. Like it's something which people will eventually want as an option, but it's not something which is like blocking. It's like a bonus feature of MetaVault, rather something that's like part of the critical path of MetaVault.
Okay.
When I was developing in the hackathon, I was reading the documentation, and at OpenSea they are like looking for integration, and there are several comments like if you have an standardized way to store images, for example, and you want to show them in the OpenSea site, please contact us and give us your standard, and we can implement, for example, a way to show the image not from IPFS, for example, but from Subspace object ID or something like that, for example, just to know. So they are open to, for example.
Okay, and how many options beyond IPFS is there right now? Maybe it's like enterprise inquiry, so you need to like work with them and maybe pay them, or there should be like a big traction for that to actually be interesting to them.
There are no other options.
I think that they are using Arweave and IPFS for now.
Yeah, I believe I believe Arweave is supported.
Arweave supported in OpenSea, so you can show images and click download links from there in OpenSea.
And really, we don't actually need to integrate with OpenSea. As long as we just integrate with IPFS, then we can reuse the existing integration.
That would be ideal.
Because IPFS is going to be a better user experience anyways than retrieving from Subspace cold storage. It's going to be faster. Just if it loses the pinning, that's kind of the bonus feature of Subspace. It's like the backup in case it's no longer pinned. So that might be the thing that we want to do, but that might be like more of a higher level IPFS integration than, like IPFS.js could have maybe some, we could submit a pull request to that where like, if it's a certain content ID or like whatever namespacing they have for Subspace, then it might have a fallback mechanism to try to fetch it from the Subspace network if it's no longer on the IPFS network.
Oh, I like how it's on that, like a second layer, some kind of automatic backup. You mean that kind of integration? Like you upload something to IPFS and you got this option to make this cold storage in Subspace, something like that?
That's another approach that's valid. But I guess what I'm getting at more is that there would be a way for IPFS to know that something being stored on IPFS is also stored on Subspace, like a content ID. And if that content ID did not resolve on IPFS, that it would know that, okay, this is a Subspace ID, so I have a backup retrieval path where I can fetch it from Subspace, and then I can repin it or like re-announce it on IPFS. Or we could even just provide like a network that did this, I don't know, by default or something. Just an idea, just thinking out loud here. Because if we did that, like if we integrated the source, then we wouldn't have to integrate at all the different points that are integrating with IPFS. We just get it all, basically. Okay. Let me give you just a little bit of feedback, Leo, and then let's. I know we're over time here, but I think we still got a lot of information to cover. Does anybody have a problem with going over? You know, maybe have a 2-hour meeting today instead of a 1-hour meeting.
No problem.
That works for everybody. Okay,
works for me.
So great. So let me give you a little feedback, Leo, and then let's just take a few minutes break, and we'll come back and let Serge talk about what he's been doing with NFTs. So I think, like I said, this is really good. It was a learning process. It was us trying to figure out like, well, what is the actual data flow that we need to make this work, and what are the user experience challenges? And we've seen that there's quite a few of those. So now we at least kind of have an idea what the problems are that we have to work with. And I think there's a combination of like things we can do in the backend architecture to simplify the design as much as possible, to kind of boil it down to the bare minimum essentials, and then figuring out like how do we simplify that on the user experience point of view, which might also require some engineering as well on the front end side. But I would say, and I know a lot of this was constrained by sort of the rules or the objectives of the hackathon, versus just if we were doing this in isolation. But again, when we're going to these hackathons, and this applies like to Serge or anybody else in the future that's at one of these hackathons, we're not there to win. Maybe we don't even really want to win. We just want to learn and see what's going on and get the experience. So we don't need to worry so much about like what the, optimize for winning. We want to optimize for learning. So in this case, I would say, since there's a lot of complexity going on here, there's things that we can sort of pare down and think about for maybe like future improvements in a roadmap. So like in this case, I would think that the bare minimum is mint an NFT on some smart contract blockchain. That could be Ethereum, could be Near, could be Solana. One day it could be Subspace, and then store the data on Subspace, and keep that data down to as few files or objects as possible. Ideally, it would be one mint and one object store. That would be the goal if we could figure out how to get to that, just like 2 transactions, basically. And then figure out like how do we merge those into like one meta transaction, if that's even possible. We talked about a lot of different ways to do that. The IPFS is interesting for sure. That's an optimization, and that's like a whole nother separate integration that we need to think about almost independently of the NFT thing. But it's good to see kind of what the challenges are for that here. The OpenSea piece, I think, is definitely not even an optimization. It's just like an additional feature, which we probably don't want to worry too much about in the future. And then anything like, especially with Ethereum around L2s, I don't want to touch that right now, or on other networks. I just like to first figure out how to integrate with the layer 1s, and make sure that we've got that process down like as perfect as we can get it. Then we can figure out, okay, how do we extend this for a layer 2? So yeah, ideally like 2 transactions or 1 meta transaction, create a collection, create an NFT, and then like store the metadata on Subspace, and figure out how to just get that down as simple as possible on like the create and then the render side as well. So just as we go into future hackathons or those that are focused on NFTs or Metavault, that's kind of the kernel of what we need to get.
So basically, when we combine those two transactions that we have on Subspace side, we have one on Ethereum, one on Subspace, right?
Yeah, I think that the first step will be that, like, the first improvement will be to this both transaction in just one, and it should be easy actually. You have just to create the transaction offline and sync them in just one transaction.
Is there a way to make batch transactions on Ethereum?
Yeah.
What I was thinking is, what if the user interface was something like you configure things and then click apply? So instead of creating a collection first and then adding item to collection, you can create a collection, you can add item, and then in one step you can create collection and item, you know? So
Yeah,
you can like batch 4 uploads into one Subspace transaction, and you can batch creation of the smart contract and call to that smart contract in another transaction. So instead of like 6 right now, we will have 2, one on each side.
Yeah, I think that in this use case, it's not like possible to do just one transaction, because we have the collection deployment, and after that, I can trigger multiple transactions over that contract.
Right. So on Ethereum, it will be 2 transactions, but we can probably collapse everything to one on Subspace side because it's just objects.
Yeah, on Subspace, yes, I think. On Ethereum, I think that the minimum will be 2. Yeah, the deployment and the minting.
And create collection.
Yeah. And the other thing is, like, for the demo purposes, we're trying to get this down to as quick as possible. But in the real world, like, somebody's not creating a collection, somebody else is going to mint after the fact. Like, the create collection is kind of like the deployment of the whole contract, but then users might come in, or the creator might come in and periodically mint new tokens. So it's not super critical to get those down to one step.
Got it.
Okay, cool. Any other thoughts or questions before we take a break? Okay, great. Thanks, Leo. Let's take
guys.
5, and we'll come back and switch gears here. All right, get everybody here. Let's get back to it. Serge, if you want to take it away and walk us through what you're doing with Palette Uniques, please.
Sure. So let me share my screen. Okay. So I guess you can see it. Yeah, so here we're connecting to Westmint. Let's go. It's a West End testnet, and Westmint is similar to StateMine and StateMint on Polkadot and Kusama. So it's.
Hey, Serge, before we get into it, could you just give us kind of a high-level overview of what you're trying to achieve here?
Yeah, so I did some research on .sama NFTs, similar to what Scholar did, but with a focus on development experience. And so far, I've created a simple application for to interact with Palette Uniques, and Palette Uniques is the one which is used for those chains I mentioned: Westmint, StateMint, StateMine, and some parachains also use Palette Uniques, like Centrifuge and like lesser known parachains. So it's like a standard palette. It's by parity, it's part of the frame. Standard palette for non-fungible assets. And just a note, for on those chains, StateMine, StateMint, and Westmint, you can also create fungible assets, but they use another palette for that. And yeah, so this application, it's a React application, and it interacts with Palette Uniques. And we can create a class. Every class has a team. The team is an owner, a freezer, and someone else. I forgot, some other person.
Is Palette Uniques compatible with the ERC 721 standard?
I haven't done any comparison yet. It's on my list. Yeah, we discussed previously that I will create a table that will compare basically ERC 721, ERC 1155, and Palette Uniques. So yeah, I don't have like the exact comparison at the moment, but on a high level, they have similar functionality. So first you need to create a collection. In Palette Uniques, it's called the class. And under this class, you can create an asset, mint an asset. And one like significant distinction is on Palette Uniques, NFT, an asset is by default not immutable. So after you mint an asset, you can still update metadata, add attributes, like edit it in different ways. And once you're done, you can send additional extrinsic to freeze asset, and after it's frozen, it becomes immutable. Yeah, let me show you how it works. So we are connected to the Westmint here. Let me check my Westmint account. I can show you. Yeah, we have some Westies, the tokens of the West End parachain. So in order to use it on Westmint, you need to teleport them from West End first. Let me show you real quick. Yeah, so we are on the West End. Imagine it's like Kusama relay chain, and we go here and we click teleport. We select the destination chain, Westmint in this case, account, and yeah, I still have some Westies here to transfer, but I'm not gonna do it. And after you transfer, you can use Westmint and use those assets to create class and mint. Yeah, so we have this account. These are the classes already created in the palette. And I think I already did some. So yeah, I have created 2 classes here. And
Are those like collections? Or what is
yes,
it?
classes are collections. It's just different naming. So yeah, we can check other people's assets. So here's a list of assets. Some of them have metadata, some of them don't. Yeah, so this one doesn't have any metadata. This one has, and it's not frozen. There is this another distinction, deposit, and this has something to do with the storage. So the bigger the size of your JSON, the bigger
It's
has to be.
kind of like existential deposit. You need to like pay some amount per byte.
Yes,
As you
exactly.
add, you need to pay. As you remove, it will be refunded to you.
Yeah, unfortunately, there is no doc. I was reading the palette, and this is what I could understand.
So this is a state rent, right?
Kind
Basically?
of, yeah. Yes.
I thought that they had removed that from Substrate because
That's
there was
different.
like a revolt from developers.
They kind of added it. So previously they had the state rent, which basically removes fraction of tokens every block or epoch or whatever. Now you just like for every byte that you add to state, you have to pay like a fee for that, and if you remove from state, you are refunded for the amount of space you freed.
Oh, so it's
So
like
this is
state
not like
staking.
it's not ticking; it's like fixed cost basically.
Yeah,
Oh, I see.
after you burn an asset, you will get this deposit back.
Does the cost change or is it constant?
It changes if you add more fields to the metadata.
So basically,
mean,
it's proportional to volume. I think it's constant parameter.
I mean globally, not for any particular contract. Like as the state gets more utilized, does it get more expensive? I guess as the state blows up on
I
the
think
chain,
it's
or is
just
it
like
always
constant.
the same?
I think
Okay.
it's fixed. Yeah.
Okay.
Okay, so here I have different steps. This is not everything that Pilot can do. I just implemented like a basic workflow, and here I created like a separate extrinsics, obviously with Subspace with Substrate and Polka.js. This can be a batch of transactions. But yeah, let me just show you. We can create a random class. And I didn't implement UI for transactions. We will read it here. We have to wait a little bit. Oh, it's not successful for some reason. Maybe I don't have enough funds.
Yeah, that's beautiful. Index 10, error 2. Go figure what is the pilot index 10 and what is the error in it with index 2.
That should be enough.
Okay, why don't you just walk us through with an explanation of what it does, Serge?
Yeah, so first you create a class, and then you can mint an asset. You have to specify the class ID. So when you create a class, you specify class ID. I think we can mint an asset for one of the classes I already have. So let's say this one. And after you mint an asset, you can add metadata. So here you have to specify the class ID, asset ID, and metadata is a string, can be like object ID, can be, yeah, this one was successful. Let's go, yeah, here is our specified ID 12. So here is our asset. It has no metadata, so we can go and edit. And let's just not freeze it at this stage.
When you freeze it, you only freeze like the addition of the data, or also the transfer and the burn and everything?
No, you can still, you cannot edit it, but you can still transfer, burn, and do some stuff with it. You cannot just edit it.
So it just makes it immutable.
Yeah, right. So as you can see, it's not frozen. Our metadata is included. And yeah, we have this deposit, and we can update it and freeze. Yeah, and once it's frozen, if you try to submit extrinsic to do anything, to edit, it will just fail. Yeah, it's another object ID now. And yeah, we can transfer it to someone. Let me check. Yeah, I can transfer it to Alice.
Okay, Serge, you don't have to show us all that functionality. I mean, if you just explain it to us, we trust you.
Okay, yeah, you can
Seems pretty
transfer,
standard.
and you can burn asset as well. Yeah, basically that's it. Let me just check real quick what's available in the palette, what I haven't mentioned. So you can delegate transferring with this extrinsic. You can also set attributes. You can set metadata, and you can set a particular attribute for both for class and for individual asset. You can also destroy the whole class. And yeah, you can edit class and freeze class similar to what we did with an asset. And yeah, basically that's it. So the team is issuer, admin, and freezer. I don't remember what is issuer. Probably issuer can only create assets. Admin can do everything, and freezer is the person who can freeze assets. Yeah, I guess that's it.
And you can unfreeze a class too. That's what the thaw is.
No, I think once it's frozen, it's over. You
And what does thaw do?
Thaw reallow unprivileged transfer. Yeah, something with a transfer.
So that sets who the admin is. So the issuer could transfer ownership of the class to someone else, but then they could lock it or unlock it. But once it's frozen, you can't change the metadata. It just seems weird they would choose thaw. Seems like the opposite of freeze. Okay.
There is also another pilot. It's called ORRML NFTs. This was before Pilot Unix. Most of the parachains were using this one, and I think BitCountry still uses that one. But yeah, after Pilot Unix, I think it's kind of standard now. The API is pretty similar.
Okay. Do you have any integrations for this that work with Subspace for metadata storage?
No.
Okay. Do you have any thoughts right now on how you might integrate that? Would it be similar to what Leo did, or had you considered that yet?
Yeah, I created this lucid diagram. Let me find it. Similar to what Leo had for MetaVault flow, maybe this one. Yeah. Can you see it?
Mm-hmm.
Yeah, so basically you go to the web page. First, it will we didn't have this step right now because I already my extension is already aware of this application. But when you launch it for the first time, there will be a pop-up like connect Polkadot JS wallet, blah blah blah. So you do that, then you go back to the page, and you first in this flow. First, you store the item in the on the subspace. So we are initially connected to the subspace. We store the item, we submit extrinsic, we sign in Polkadot.js wallet, it goes to Subspace network, and we're back to this like web page application section. After that, we can switch to the, I think I forgot this step, switch step. Okay, I will add it later. Let me just leave a note. Okay, so you switch to the state mint, state mine, or west mint. Here we have this step. So we switch to another network which has Pilot Unix. We change it on the Polkadot wallet. Actually, no, we don't have to change it here. We switch on the web application, and then we can create a class, mint NFT, we sign extrinsic, and when we mint NFT, in this case, I submit batch extrinsic. So we submit one extrinsic that will mint and set metadata at the same time. Potentially, we can use we can create a batch for both create class and the mint part. So this can be optimized. And after that, we are done. So we don't have OpenSea, obviously, here. So it's a little bit simpler. Any questions on this?
Yeah, you're using the same account for Subspace and statement? You just changed the format. How did you do that?
Yes, you use same key pair.
Oh,
The actual address can change, probably. maybe
It just
not.
says 58 representation because the network prefix is different.
Yes, but you use same pair.
Perfect.
I'm just curious. No, thanks, Serge. This was a good overview. I mean, it makes sense to me how it works. I'm just thinking out loud here again. I'm curious. All of these examples that we've done so far are creating a new collection, creating new NFTs or new items within a collection. The way that things work with ERC 721 or with palette uniques, would it be possible to, if item is to like update an item, update the metadata for an item so that you could take something where maybe it's currently only stored on IPFS or it's currently only stored on OpenSea and like upgrade it so that the data, the metadata is captured or the file data is captured and stored on Subspace, and that gets pinned into this contract?
I was thinking about this, but I'm not sure we can edit like NFTs on, let's say, Ethereum. One workaround is we can burn them and create new ones, like on the same chain or on the other chain, with new metadata that will include like Subspace
That's not the
object
same
ID.
NFT anymore.
Yes, but most people won't do that. But yeah, once it's minted on Ethereum, you cannot change it, unfortunately.
Well, on one hand, yes, and that's like the whole point, that you have something which is immutable. On the other hand, if we support IPFS, then it doesn't matter whether the link was on IPFS originally, or like whether it was uploaded to IPFS originally, or whether you upload later the same exact content to Subspace and it is available using the same link. It will be the same IPFS ID in the end. So in this sense, we are kind of like an upgrade, just persistent pinning for the object.
Could you clarify? It's not clear to me how that would
Okay.
actually work.
Right now, many people store images or whatever on IPFS, right? And then they get an ID. ID is basically content addressable. So it is uniquely representing that particular file or content that was uploaded. If we have integration with IPFS in Subspace and we upload the same exact file, it will result in the same exact ID on the IPFS. So it will essentially permanently pin the same exact object. So the NFT doesn't have to change.
Oh, so you mean if we represent the Subspace object ID the same way using CIDs from IPFS, then the same data input
CID is
will
basically
always...
a fancy way to like explain that this is like a SHA-256 hash or whatever of some blob.
Right,
so if you put
but
the
it's
same
not...
blob, it will be the same hash.
Right, but it's not the same right now, the way that we hash the objects, right?
We don't have CID in the first place, but if you format it as CID, it will be the
object
same.
ID, the Subspace object ID.
It will be the same. Like if the hashing algorithm is the same, I don't remember
but it's
what
not,
it is.
Right, but it's not the same right now, right?
It might be. I don't remember what the hashing they're using by default.
I'm pretty sure it's not. Okay, so you're saying if we upgrade our schema so that we use as our resolver the same method that IPFS uses for CIDs, then it would always fall back, or for things
It's just
that
the same
stored in
hashing
Subspace.
algorithm for the content addressing. As soon as the hash function is the same, it will be the same.
Well, I don't think it's that simple. I think there's more complexity as to how the IPFS works. I think there's something around like namespacing and some other stuff they do with the data. There's like some wrappers they have around the data.
That is
it's not
if
just
you want to
purely
store
the
like
data.
a folder, then you have kind of like manifest for the folder, and then you have like a tree basically structure. You have like multiple files, and then you like grab them together, create like a folder, and then another folder. Like that is, I think, why they have like more complex structure. If you just upload an object, I don't think they would use that. Even then, we can like create this wrapper and like hash it. Well, it should be doable on Subspace.
Yeah, it's doable. I'm just saying it's not like that simple.
Okay.
Yeah. Okay. So if we did that, then anything that's on Ethereum that has a pointer to IPFS already would have like a backup resolver basically onto Subspace.
But if it's stored on IPFS, we can just replace JSON with another one that will include Subspace object ID.
No, that's the whole point of IPFS. It's content adjustable. As soon as content changes, the URL changes as well.
Ah, okay.
And the question is if it's stored on IPFS. That's the big problem. Okay. Leo, any thoughts on that about NFTs, how that would work?
No, just a comment in terms of updating the NFT. There is people normally just remain the NFT itself, and that's why most of the apps are moving to a layer 2 or everything, because in that use case it's expensive to do it and keep doing this in Ethereum. Actually, for example, Unstoppable Domains moves everything to a layer 2. They are now just registering a layer 2 because when they have to transfer and update the domains NFTs, they were spending too much in Ethereum. So they are now living in a layer 2. So it is not like a bad usage, this reminting strategy to update the NFTs. But thinking in Ethereum will be expensive actually.
Mm-hmm.
But it doesn't happen too much actually.
Yeah, I mean, wrapped NFTs is like a big trend that we've seen a lot of lately, and there's nothing to stop you from wrapping an NFT and adding a subspace hash to it. There's also another thing I was thinking is we might have some sort of a subspace DNS, in a Ethereum name service or IPFS to subspace, like mapping on Ethereum, for example, where you could look up a NFT's ID and find its subspace hash through that if you wanted to, and you could have like a signature of the owner, creator of the NFT, something like that, to verify that actually is the right. Well, I mean, it's content addressed at the end, so it should be verifiable. But yeah, I think there's a couple different ways to get at this. Just something I'm thinking, like, we're trying to do this from first principles, and that's the easiest way. But probably there might be a lot of people that would want to migrate or update their NFTs in this way, and we just need to think about that use case as well.
Yeah, a small note on that. Affinity has a bridge for NFTs. It's like in development, but yeah, they're thinking about that.
To Ethereum?
Multi-chain. Ethereum substrate.
Okay. Those would be two different bridges, but okay, that's interesting. Yeah, I know a lot of the game developers I've talked to are already wrapping NFTs and moving them across chains to whatever chain their game is on, or their L2 their game is on. So it seems to be a pretty common thing that people are doing nowadays. And even like, I don't remember which one it was. There was some collection lately. Was it like Pudgy Penguins or something like that, where they had like a revolt and people were like wrapping the NFTs and taking them away from the creators because they didn't like the way the DAO was going or something. Okay, cool. All right. Anything else on the NFT discussion? We'll wrap that up. Any thoughts from the peanut gallery, Sky?
Peanut gallery. Oh, no, I don't really have any thoughts. I'm just following along, listening. It's good to see how these things are going on in the background. So I'm coming up with similar solutions just like a few minutes after you guys. So peanut gallery is great, I guess.
Great. Okay.
Are we thinking? Are we planning to add these palette uniques to our chain at some moments? No.
Yeah, that's a great question. We are thinking about it. So we are trying to figure out what is the, like in Ethereum, there's 10,000 smart contracts, but 50 of them get called 90% of the time. And so there's a question of, well, are there some like very, very common use cases that we want to like hard code basically into Subspace as palettes versus being smart contract logic, so that we get the advantage of not having to do the gas metering and having like a standard that everybody can use and not everybody having to deploy their own implementation. So it's something we're thinking about. We don't have any firm answers yet, but we're thinking probably like maybe what StateMine has with like minting a fungible token, a non-fungible token, maybe like an exchange, like a name service. Like there might be a handful of these like business, logic use cases that we put in. Yeah, so we'll have that. We'll probably have like, this is something we're going to talk about tomorrow a little bit at the all hands meeting. We'll have a bunch of like primitive APIs, like APIs for storage, APIs for compute, for cryptography, maybe for cross-chain messaging as well. And then we'll have like a smart contract framework as well. And ideally we'll have like an abstract wrapper around smart contract frameworks that allow you to deploy different smart contract frameworks, so that we not limited to one, but we just have a notion of like abstract contract. And we could support different VMs. This is something that we're thinking about, but ideally it would be, there'd be a lot of flexibility from a developer's point of view of how they could do this if they wanted to focus on like customization and like being as permissionless as possible, or if they were just more concerned with like efficiency and standardization, they would sort of have a choice, or even which language they wanted to use, or if they wanted to use the primitives that we have to reconstruct their own thing, not even using smart contract language, but just using our API as like building blocks for some functionality. We're trying to give like as much flexibility to the developer as possible. Does that make sense, Leo? Okay. Go ahead, Serge.
Yeah, I wanted to, maybe we can sum up in the context of near hackathon regarding MetaVault, because we identified few issues today, like few directions we can move. So I wanted to know, because yeah, I have to talk with Todd and the team, like Diana, after this. So I want to have a plan.
Yeah, thanks for bringing that up. I forgot about that. So where I'd like this to go. So right now we're doing research, but we're also trying to figure out some standard implementations and kind of build a library of examples, basically. So maybe in a month or 2 months, I'd like to have a repo, maybe part of Subspace.js, or maybe its own repo of like NFT integrations, Subspace NFT integrations. And there's like an Ethereum folder. This is how you mint an NFT on Ethereum, stored on Subspace. There's a StateMine folder. Okay, this is how you do it with palette uniques. There's one for Ink. This is how you do it with Ink. There's one for Near. Okay, here's how you do it with Near. One for Solana, so on. So right now, all these different ones are kind of going off in their own direction, which is okay because we're just in experimentation phase. But we need to come up with sort of a basic set of requirements for what this has. And right now that is, in my mind, that's mint an NFT, create a collection, mint an item, store the object data or the metadata on Subspace, and have some kind of a UI for doing this, which I think React, is that what you were using, Leo, in yours as well? Was that React? Yeah, so probably just like the standard like React template is what we want to use. And all of these different examples will have that in common, but they just show how to do that in these different cases. So the idea is that first we're going to figure out like manually how to write all this stuff across like the 4 or 5 most common use cases. Then we're going to step back and think about, okay, how do we design like a meta API over all this? what do we need to integrate? Like, what do we need to hard code into Subspace? Maybe we have like a palette uniques in Subspace, or maybe some other calls. And then how do we then kind of wrap this functionality into Subspace JS? So it's more ergonomic for developers. They're not having to like write all this stuff from scratch. They could if they wanted to, but so that's the high level goal. And then this will eventually be the Meta Vault, or whatever we're going to call it, like service for Subspace meta services. Yeah, I lost my train of thought there, but yeah, does that answer your question? Yeah, and the hackathons are kind of our way to build out these different facets of Meta Vault and come to the standardization and kind of understand the problems across different chains until we cover like the core use cases, or sorry, the core ecosystems.
Okay, I think I got it. Like integration is a #1 priority, and we mint NFT store and Subspace.
Yeah.
Nothing fancy.
We just want, yeah, nothing fancy. No, nothing fancy. Just learning how do we get the minimum viable product of like abstract mint an NFT on some chain, store the data on Subspace, render it, retrieve it, store, in a UI. That's really what we're trying to achieve in a meta way. So I guess one of the key points here is the meta is not like, don't get wrapped around the axle that meta means metaverse. Meta just means like at a high level, like, cross-chain, cross-ecosystem, which is kind of like just another way of thinking about L0, but from top down versus like bottom up. Okay. Yeah, so with that being said, so Serge, I think you understand what to do with the near hackathon. With these particular examples that we've got now, what I'd like Serge and Leo for you guys to do is kind of get together and figure out what is sort of the minimum viable product, or the minimum viable interface, or whatever that we want for these examples, the template for these examples. And then once you guys figure that out, let's define that in like a README, kind of like a specification, create a repo for this, and then refactor what we have for Ethereum, what we have for Substrate, and add these two. And then we'll just keep adding to these, and then we'll incremental it, and then maybe there'll be another one for like an IPFS integration. But we'll just keep adding this stuff in, and we want to kind of do it in a way that's composable. But we're going to start with the simplest parts.
Should we include the lucid diagram for all examples? I think it would be useful, like for README.
Absolutely.
Okay.
Yeah, so do you guys, but the next time we meet in 2 weeks, I'd like to see that. I'd like to see one repo with at least two folders, one for minimum viable Ethereum implementation, one for minimum viable state mine implementation. Maybe we'll even have a couple others in there by then, but that'll be a building block. Okay. Do you want to talk about the relayer a little bit, Serge?
Yeah, sure. Let me share my screen again. Okay, so what has been updated. First, I added the new parachains to create archives. We already discussed it. Zeitgeist and Pointer, Robonomics, Crust Shadow. Crust Shadow is working for now, but earlier it didn't work. So let's hope it will work. And Sakura, Subsocial, and another parachain. There are some issues like endpoints do not work. And yeah, I created issues, as I mentioned, on GitHub, and no response yet. Another thing I have added is a script, so we can add a single chain. So we create the feed and fund account to add a single chain. Like, for example, we want to add Zeitgeist. We don't have to restart everything. We can just run this script with para ID, and we add a Zeitgeist chain. And I have added monitoring earlier with Prometheus. So now we have a counter for number of blocks, number of batches, and like default metrics. It still requires some integration with Datadog, but yeah, it was postponed. It's something on my list. Yeah, I guess that's it for Relayer.
Any blockers right now?
On Relayer, no, except like these new parachains, nothing is blocking. Yeah, test B was already updated today, and I think UI was already updated as well, merged today. Yeah. So those 4 parachains should be public.
Okay. Leo, you had some stuff about the Relayer front end?
No, just like Sir mentioned, I already deployed this and they are already in the public interface. And Cointer, SafeCase, and Robonomics, they are available out there.
Okay. Skylar, or you make sure everybody on the business team's tracking what chains are live and which ones are added to the list for day one for announcements and everything?
Yes. Yeah, I'll have to let them know. I guess I was just thinking about this side of the workflow, about getting them up on the Relayer. I'm actually talking with Diana right now, so I'll see if there's anything missing from her. But it should just be easy notifications. We usually just do ats on Notion if we do.
Okay.
So
let's make sure that those new parachains are also added to the announcements calendar as well, if they're not already on there.
Okay. Yeah.
Okay. Cool. Okay, I think we're good for today. We're almost over 2 hours now. Anything else you guys want to cover? Any open items or issues?
Should we schedule this meeting next time for 2 hours? I think it's valuable.
Yeah, I agree. It's really valuable time. We hash out some important questions here. I think maybe 1.5 hours. It was just long because of the Leo being out and not being able to go through MetaVault in detail. But yeah, let's update it to 1.5 hours from now on. Okay. All right. Well, thank you everybody for watching. Hopefully it was enjoyable. And we'll see you guys again in 2 weeks with some exciting updates.